Hello everyone, thanks for watching this. This is Justin Castillo with Elastic. I owe you a talk on deep agents with Elasticsearch, and so I am delivering. If you have any questions, you can ask it in the Slack channel under the thread, or feel free to message me directly, and I'll be more than happy to walk you through any of the code. So today we're going to learn about LangChain's deep agents agentic harness, which basically takes an LLM and gives you the ability to create sub-agents to accomplish a larger task. I am including Elastic, of course, and we use Elastic throughout a couple of the different sub-agents to get our tasks done. And hopefully I'll be able to run a demo for you throughout this process so we can actually see this working, and I'll hopefully get you inspired to run it on your machine. So part one is going to learning about LangChain's deep agents framework. It's somewhat new. It hasn't really been touted a whole lot, but I think it deserves a little bit more attention than it actually receives. So we all use LLMs, or we all have, and the challenge is that we're actually using one single LLM or one single agent at any given time. That can be difficult when you're actually trying to accomplish longer goals that require them to keep their context very specific and consistent, and for them to actually take knowledge, transfer it, synthesize it, and use that new knowledge to accomplish a new task. We also have to give it a lot of context as far as like domain knowledge. So what it has to do. So like you are a friendly customer service representative, or you are a data analyst, or you are a marine biologist. We tell the LLM all these directives to give it sort of a focus, but that can be kind of confusing when it has to do the work of maybe 4 or 5 different entities to get your goal accomplished. Also, an LLM has to actually execute tasks in series when it's actually on its own, whereas sub-agents can run tasks in parallel. So this is how we kind of experience things with like Claude Code or Codex, where things can be spawned, little agents, sub-agents can be spawned in parallel, and we can see them actually achieving tasks while it's doing something else. So here is the basic structure of deep agents. So you're going to see this throughout all of the deep agents, agentic harness frameworks. So we have the orchestrator agent, which could be thought as your main boss LLM, or the main controlling agent. It decides which sub-agent to call, which sub-agent to execute with parameters, and it receives information from the sub-agents to synthesize some kind of output that is requested of it. So an orchestrator can create sub-agents, which are going to be just instances of itself, of an LLM being called to do specific tasks. This can be any number of sub-agents. I don't really know how many you can call, as many as I would imagine your bandwidth can accept. And what's also cool is these sub-agents can also call upon other sub-agents to verify their work, to do sub-tasks, what have you. Orchestrators can also check the file system that is allowed to them. So if you have local files, config files, envs, things like that, that you want the LLM to have access to, it could actually check those file systems. You can also use planning tools. So one of the things that I absolutely love about deep agents is that you can actually see the to-do list that it creates, and it creates this live. For the more complex tasks, it will actually create a very, very well thought out design document of what it plans to do. For things that it has confidence that it's going to accomplish relatively simply or easily, it's going to have a much smaller to-do list. And I actually have that in the application that I wrote to demonstrate this, so we can actually see it in action. All right, so a little bit more about the main coordinator. It is the first LLM that you talk to. It's what you interact with. It's what you give the information to start off the task. Once you have that information given to it, it decides what sub-agents it wants to actually start off and run with the correct arguments and parameters. Based off of your context and your prompting, it can run different agents in parallel, or it can actually run them in series, or you can wait for certain sub-agents to come back with information before it makes other decisions. This is all actually handled within the prompt that you give the main orchestrator. And lastly, this is the final agent that you want to create the output that you want. So this could be the final document. So for in our case, I want a quantitative and qualitative analysis of a new technology or a comparison between two different technologies. My main orchestrator is the agent that actually creates that output rather than a subagent. And a little bit about subagents. So subagents and tools are two separate things that we have to write out, but they have different tasks and you want to keep them actually separate. So subagents have their own prompting and they focus on a single domain of knowledge. So one can be, for this instance, a GitHub API researcher, basically. So it contacts GitHub's API and it looks up at technology. It evaluates their contribution metrics. It checks out how many people have starred the products, how many people are watching it, how many people have forked it to their own repos. All of these are valuable numbers that shows like how much the community at large is actually engaging with the actual repository. And again, this can call other sub agents if you did want it to. So if you wanted to actually go through all the commits of a specific repository through GitHub, you can go through the commit messages and kind of build a story of how it was developed, things like that. The thing about sub agents is that once they are created and summoned by the main agent, they are just completely executed, well, in a more morbid way, but they are just completely disappear after you're done using them. So with tools, this is what makes, I think, deep agents really approachable for everybody, is tools are just basically atomic functions. You can have them do basically all the functionality that you would have any kind of microservice do. Connect to an external API, perform any kind of analysis. In our case, we also have it storing and retrieving data from Elastic. The GitHub metrics and the GitHub sentiment analysis, and also our web search subagents all store snapshots into Elastic, so we don't actually have to reach out with the information retrieval if it's been within, I'd say, a day of GitHub metrics or a week for a web search. So this is actually kind of a form of caching, and I would never actually recommend using Elasticsearch as a cache because that's just a little bit overkill. But I wanted to show the ability of using Elastic to store many different forms of data. So here's the basic example of creating the first main orchestrator agent. This create deep agent is from the actual SDK of LangChain's deep agent framework. You can see I'm choosing Sonnet. I picked this one because it doesn't overthink things. It doesn't take too long. I've tried some of I've tried Opus, I've tried GPT-5. It's just a bit long-winded. So I found that this is the perfect LLM to use as the orchestrator and also for these subagents. And then of course we have a system prompt that kind of explains what it does. So you call different subagents to gather data, you compile all of that data together, and then you finally synthesize a result. It's much bigger, and I encourage you to check out the actual system prompt, but basically it just says you are a developer advocate. And it has its own actual tools, and you'll see here I have find similar and calculate score. Find similar is going to actually kick off a different branch of like research a new technology or research a certain technology. That will actually take two different technologies and go through the process of researching both of them. Calculate score is actually going to take all the numbers from the metrics, all the values from the metrics, and create a viability score to kind of compare to two different technologies together and decide which one it would outperform the other. Now this isn't based off of some deep-seated algorithm or anything like that. It was just the way to give it a simple numerical comparison. And then we also gave it a list of subagents. We have metrics subagent, sentiment subagent, and web subagent. And we also include an Elastic subagent in the end. So here's an example of the system prompt for the orchestrator agent. And you can see the delegation rules. This is one part of the entire prompt. And we say delegate to metrics agent, sentiment agent, and web agent in parallel. And we explain to it, they don't have to depend on each other. wait for all the results, and then use Elastic Agent to check historical data. So this actually gives like a really good snapshot of like what the current information is, what information have we stored previously about these technologies, and then lastly, synthesize findings into final report. This is a very small subsection of the prompt, but it gives a little bit more detail as far as like formatting, things to do. Don't overload the document in obnoxious emojis. That really bugs me, things like that. So here's the actual sub-agent prompt definition for the metrics agent. So this includes the description, the system prompt, and a list of the tools. So this is read by the orchestrator. So the orchestrator agent reads this to understand why and when. It would call the metrics agent. And then this would actually be like the definition to create and summon the metrics agent. So as we can see, the orchestrator would want to fetch, like the orchestrator would want to run the metrics agent when it wants to fetch GitHub repo metrics, all the values that I was speaking of previously. And then this system prompt would actually be injected into the subagent LLM at the time of creation. So when the subagent starts, it knows use fetch repo metrics to get data on a given repo, analyze patterns, store snapshot for historical tracking. That store snapshot, that's an actual Elastic command. So it's going to store a snapshot of data into Elastic. And then lastly, we're going to report findings with specific numbers, and that's going to be a small report that's going to be sent up to the orchestrator. And here I have a list of the two tools that I wrote for the metrics agent. So fetch repo metrics, which is that API call to GitHub, and that store research snapshot, which is that call to Elasticsearch to store the snapshot of metrics. And so this is the actual outline of this particular demo. So this is the one that we have locally that gives us that kind of that DevRel report. My orchestrator has available to it the metrics subagent, which we went over, the sentiment subagent, which actually goes over the repo's issues and PRs, and it reads through the content. It checks how many were open, how many were closed, and also like the actual content of the issues. So were people pissed when they were creating these issues? Were they enthusiastic to actually include some like bug fixes or some new features, things like that? That actually gives a lot of information as far as how the general vibe, the quantitative vibe of the repository and the actual technology. We also use Tavili to actually call out and search the internet for content about this technology. So are people writing blogs about it? Are people mentioning it in Hacker News? Are there conference talks about it? So this talk about deep agents hopefully would show up as a talk that happened, and then the orchestrator would pick up that information and say, oh, there was a talk about deep agents. That's a good thing. So it's kind of an Ouroboros, but it works out in the end. That's kind of what DevRel is. Elastic actually is here in quite a few of these subagents writing and reading from Elasticsearch's data store as far as like what content has already been found. Can we use that as kind of a cache as like previous information? It also stores the reports that it generates into Elastic, so we can actually say, oh, for context, this technology was pitted against this other technology for comparison, and this is what we learned. It's actually going to find that report, read it, and add it to the greater report for this newest request, just to give it some historical context. And then lastly, the orchestrator has its own scoring tools that I showed you previously to convert all the information from these subagents to a larger report. And then, so now let's actually dig a little bit deeper into the Elastic Agent Builder. I think this is actually a really cool feature that made it very powerful and gives you a really good opportunity to be kind of a Elasticsearch data query nerd without having to actually work in Elastic as an employee or spend full time reading the docs. So Elastic Agent is a connection that you can make with your LLM into Elastic to basically have a conversation, an intelligent conversation with your data. So it is a no/low code implementation, but here you're actually creating an agent, as you can see in this window, giving it context and then actually writing tools to get it to actually call upon your data. You can also have it create its own tools to do the query that you actually specifically want. And you can save that tool and have it called again and again. You can also create visualizations and your own dashboard, readouts, just by having a conversation with this actual agent. Here's some examples of queries that were actually made with this agent that I actually saved to use for this Deep Agents demo. So this is ESQL. This is a SQL-like query language that exists within Elastic. And this is really good for pulling information and querying information quickly out of Elastic and creating, you can create deeper aggregations, transformations. You can, join different indexes together. You can do approximations over large, data sets, what have you. This is more of like a simpler search query example because I didn't want to get that deep into that section of Elastic. But here we go, searching for a simple keyword search. So for my technology research index, where the repo is actually coded to langchain-ai/langgraph, where the timestamp of its creation was after January 1st, 2025. This should be pretty, straightforward for everybody to understand who has prior experience with SQL, but also you can understand that this would actually transfer over to like a non-SQL database. On the right is an example of semantic search. So semantic search is when you have that non-keyword semantic similarity search, where if you're looking for red shoes, you can also ask for crimson greaves or burgundy slip-ons, things like that. It just knows you're looking for red shoes. So this is the actual query where semantic content is AI agent frameworks Python. So it would know to show me all of the different AI agent frameworks in Python. It could have not those words in the actual title or those actual words in the title, as long as they're somewhat similar. And here's an actual call for me to create a tool. Once I have that query that the agent made me, I can actually do this programmatically with an API call. This is absolutely optional, and you can actually do this within our own UI called Kibana. But I just wanted to show you that you can actually, do this once you've interacted with your LLM that's been connected to Elastic. You can create this on your own if you should choose. Basically, you just send the API call, a post to the Agent Builder Tools section of Kibana, and you just pass in your query with a description of what the tool does, any tags you want, the parameters that you want to actually include, things like that. Okay, so this is the Elastic sub-agent design. This is the actual sub-agent that's going to contact the Elasticsearch for the deep agents and actually invoke any of the tools that we've created. So you can see I'm just connecting to the client here, setting the headers, and I'm calling invoke tool, which is going to basically just send a request to this API endpoint of the tool that you created /invoke, and you'll pass in the params. And we'll come back with your query response that you can actually pass to your orchestrator. Here's another one that I wanted to show. This is when you actually just want to chat with the LLM agent that you created, that Elastic Agent Builder sub-agent. Wow, that was a long title. So you can call just this chat and it will actually send your conversation to the agent. And you'll notice that it has this conversation ID that just maintains the conversation. So if you have multiple people sending, chat requests to your agent, then it will know, oh, who am I talking to? Oh, I'm still talking to Justin about this. So that's basically it. And here's the actual sub-agent design. So again, all of these sub-agents have to have prompts. And so here's the one for Elastic, search for similar technologies, retrieve historical trends, check caches before API calls, get adoption signals and reports. These are all the things that it should have confidence that it can do. And then near the bottom, the system prompt, that's the most important part. You're an Elastic data specialist, ESQL queries with parameterized inputs, semantic search with metadata scores, and check caches before expensive API calls. And then we give it the actual tools. Again, this is a much smaller prompt that actually exists, but I wanted you to see what different tools it had access to. Okay, So here's the actual demo. So this is just the front end, and these are going to be the different cards that show the activity from all of the different agents. So we'll see the plan for the orchestrator, which is that to-do list. Here's the actual activity of the orchestrator as far as what is actually triggering. And then these are the different agents, the metrics agent, the sentiment agent, the web agent, and the elastic agent. And we'll be able to see what functions they're calling. And we'll get to peek a little bit into the responses that they're getting and what they're sending back to the orchestrator. So usually around this time, I would ask everybody to volunteer an interesting question to compare different technologies, or ask if your startup has what it takes to be the next React killer or something like that. But unfortunately, I'm in my hotel, so I'll ask a pretty innocent question that I think that won't ruffle too many feathers. Should I use Elasticsearch or OpenSearch for my semantic search needs? Honest question. Not connected. Fantastic. Let me refresh. Okay, now we're connected. Should I use Elasticsearch or OpenSearch for my semantic search needs? Okay, so it received that query. It's initializing the agent. Agent ready, starting research. It's created this plan. So dispatch Elastic Agent for historical context on Elasticsearch, OpenSearch, and similar vector semantic search technologies. So it knows basically my question. It's expanding it into further other technologies that I can also look into. And then it's going to actually dispatch all of the different tasks. So it's doing that here. And then I can see it start up here. So these are all queries and functions that it's calling. So you'll see this cached check here. This means that it actually found data within Elasticsearch that we can actually use to support generating this report. So it created all these different Tavili searches. There's cached ones, and then there's non-cached ones. So this one is Elasticsearch ELSER Semantic Search Benchmarks Comparison 2024. That's what it asked for. Nothing was cached with that query, and we did get 10 results. And let's look up fetch repo metrics. So it's looking for repo metrics on Elasticsearch and OpenSearch project for OpenSearch. And it looks like, which one up here? Yeah, that one was cached. This one wasn't. And then any recent issues. So there's at least 50 issues with OpenSearch and 100 issues with Elasticsearch. Not surprised there. We're pretty active. And then here are all the different queries that it's actually sending through Ask Elastic Agent. So get trend data showing viability score changes for Elastic/Elasticsearch over the last 6 months. And so it's going to turn this into an ESQL query where it's going to have that timestamp, greater than last 6 months. And it's going to look for viability scores within those documents that it's created from previous reports. So one thing to note is that since this is actually multiple LLMs calling and searching data, this isn't going to be as fast as you just simply asking Claude Code or Codex or GPT. So it's not drawing on just a cursory web search. It's not drawing on the knowledge that it was trained on at its creation. It's actually reaching out and compiling information. So this, from right out of the box, essentially, is not going to be the fastest, blazing fast speed app that you've ever seen, which I think makes sense because it's actually researching and getting this information. There are tons of tunings that I can do to actually make this a lot faster, but I'm actually not interested in making it a highly performant demo. I actually want you to see this in a very open and transparent way, how these are all acting. So I'm trying to waste a lot of time by talking, and I'll just wait a little bit longer for it to actually finish off. Okay, so I see that all of the tasks are pretty much done. So now the data that I can see is going to be coming back to the orchestrator, and then we'll see all of these close off, and I'll see finally it's just synthesizing. The orchestrator doesn't choose to update the to-dos until it's ready to actually update it with like idle cycles. So that's not really good for people that are really, really happy watching a progress bar. Um, you can actually see the content coming back from all the subagents through logging and just by observing the data that's being sent between, but it's a bit of a lot of noise. Um, just one thing to point out here, I also see that it read a file, large tool results. I'm thinking that it actually stores documents locally in like a temporary file to actually read, which I think is quite smart. So it actually doesn't have anything like stuck. Yeah, so there's a lot of data. I need to actually figure out that tool call response and shorten that. Usually during a live talk, I'll actually execute this query right in the beginning of our talk so we don't actually have to wait through all this. There we go. So now we can see that it has decided to cross off all of those to-dos, and now it's finally synthesizing all the findings into a comprehensive comparison report. And these are all actually written out to an MD file. Well, each report is written to its own markdown file, just so I can actually see how it does and compare its work throughout the development of this application. And it's really quite interesting. So soon I should see a report pop down below all of these with an option to download if I want. While I'm waiting, I will take the time to thank Open Source North for inviting me to talk. I'm so sad that I wasn't able to connect my laptop properly to the display. It's my laptop's fault, not their fault at all. But I was really happy to have the opportunity to talk to everybody, and everybody was really gracious about me failing elegantly in front of everyone. And I received a lot of positive feedback from people that came back to the booth at Elastic. So I thank you a lot for that. That actually raised my spirits quite a bit, and I really appreciate it. All right, I just turned that off. So it sent that it did that. And here we go. Elasticsearch versus OpenSearch for semantic search, comparative evaluation. So it gives us a TLDR, which I really appreciate. It's still a little long, but it's still, much shorter than the main content that it's created. But here's a good thing. So it actually shows you what it figured out from the GitHub metrics. So stars, forks, contributors, how many contributors active in the last 7 days, PR merge rates, issue close rate, open issues, repository age, licenses. I think that's actually really, really useful. Community signal. So this is actually engaging with the sentiment analysis. So it's saying that right now, the hot things within the community for Elasticsearch is ESQL development intensity, maintainer responsiveness, excellent. With OpenSearch, they're working on a lot of performance and upgrades. They're okay. So we have some good community activity on working on their vector search with the sparse ANN, sidecar fields for re-embedding workflows, remote store optimization. That's fantastic. Those are all cool things. A real world adoption. So we can actually see which companies are using these just to sort of give a comparison of like, oh, me, if they're using them and I really enjoy their product or that feature, maybe it's worth something I should look into. So you can see Elasticsearch is using GitHub, Nikkei, DocuSign, or they're all using Elasticsearch Seeking Alpha, City of Sacramento. I did not know that. That's awesome. And then I can see that Uber, DataStax, Airbnb, Intuit, SAP, they're all using OpenSearch. So that's also great. I can also see some comparable technologies. So Haystack, Mastra, Deep Agents itself, I don't know about that, um, can be used with the Elastic services to run semantic search. That's a little interesting, and I might actually push on it to explain that if I was to follow up with a conversation with this report. This is actually really useful. Strengths, risks and caveats, and then recommendation. So looks like we're pretty neck and neck, and I agree with this as far as viability for the community. Cover both. Check out both and evaluate both. And check out exactly what you want versus what both create. Then final verdict. It's really neck and neck, which I think is actually great because it gives a very realistic, unbiased opinion based off of what it actually saw on the internet and not what it actually has like culturally ingrained. So don't ask me if I would recommend Elasticsearch or OpenSearch. You know what I'm going to actually say. But I let this application figure it out, and it says to cover both and evaluate both. I'll agree with it. I don't like that exactly. My paycheck doesn't like that, but that's what it says. So I hope you enjoyed that demonstration. This is the actual repository where all of that is housed. It's in Python, and it's using all of the most up-to-date tech as of, I think, 2 months ago. I have some more updates that I'm going to include just to have that UI of seeing all the different tools being called and their responses and their outputs. Thank you very, very much for watching this video. I apologize I wasn't able to deliver it live, but yeah, check out the repository, run the demo, and feel free to reach out with any questions that you might have. Thank you very much.